Finding trigonomic ratios given a right triangle. All right, so we've been dealing with the three basic trigonomic functions for about a week now. So sine, cosine, and tangent. And I have those nice and colorful over here on my notes page. And I'm hoping at this point that we kind of remember the SOHCAHTOA, because we've done this quite a few times. So this just helps you remember the three basic functions, sine, cosine, and tangent. We also have three other trigonomic functions because there are six basic functions. So if we have sine and we flip it over, so instead of opposite over hypotenuse, if we do hypotenuse over opposite, we have cosecant. So it's kind of the inverse of sine. It's upside down. And then we have cosine, which is adjacent over hypotenuse. So again, if I flip it over and I go hypotenuse over adjacent, then I have secant. So again, that's upside down. It's the inverse of cosine. And then tangent is opposite over adjacent. But if I flip it over and I go adjacent over opposite, then we call it cotangent. So they're very similar. We just have to make sure we match these ones up. So sine goes to cosecant, cosine. I don't know how to do this without really making this messy looking. Goes to this one. And then we have tangent that kind of spins around, and I'm going to go like that. So if we can remember that sine, if we flip it upside down, that's cosecant. Cosine is secant, and tangent is cotangent, flipped upside down. So it just gives us a couple extra functions here, and we get to go in and fill them out based on what they're asking. So in this case, they want us to find tangent, cosine, and then cosecant. So in order to find these, we're going to need to know all of the parts of our triangle. So the first thing they have us do is Pythagorean theorem. But they don't want any approximations, not decimals. They want exact answers. So when we go through and do Pythagorean theorem, we'd have a squared plus b squared equals c squared. And c is going to be this length that we don't have. We need it. So we have 8 squared plus 3 squared, which is 73 once you square and add them together. Well, 73 has no square root. So we literally leave it the square root of 73. That's how we leave it. And then we go through and we fill out our three trigonomic functions. We do need to make sure, actually, I was going to say we need to make sure we don't leave a root on the bottom, but they're letting us leave it that way. They're not worried about it being proper. So let's go ahead and actually start one of these so you can see it worked out from beginning to end. I want to click start. Okay, so I'm turning on my pen tool here. All right, so we have, here's our angle, and I'm going to go through and mark just the way I normally would. So we have opposite, and turn this down a little bit. Let me clear that and turn it down just a little bit. Opposite, so it's not so blurry there. Hypotenuse is always across from the 90 here. This is our hypotenuse, and I wrote right over that, didn't mean to. Adjacent, that's in between our focus angle and the 90. If you've already labeled opposite and hypotenuse, it's also just the side that's left over. But it's just a couple of different ways to describe that one. Okay, so we're going to go through and we're going to do secant, cotangent, and cosine. First, we need to know what our opposite is because we're going to use opposite in at least one of these. If not, let's see. Secant, we're not going to use opposite. Cotangent, we need opposite, and cosine, we don't need opposite. So we only need opposite for cotangent, but we do need it. So first, let's go ahead and do our Pythagorean theorem. Remember, c is the 13. So I'm going to go 5 squared plus, I'm going to go, I'll just say question mark because I seem to like to use question mark. Question mark squared equals 13 squared. So we have 25 plus question mark squared equals 169. And then we subtract 25 from both sides here. 25 minus 25 cancels. Question mark comes down, and we get, oh, it's 25, question mark squared, sorry. And we get 4, 4, 1. Well, perfect. This one actually has a square root. So question mark equals 12. So this is 12. So opposite is 12. So now we're just going to go through and fill out our functions here. And I meant to click that. That's what I was trying to do. All right, so secant, we have opposite over adjacent. So opposite is 12. Why did I say opposite over adjacent? I'm sorry, hypotenuse over adjacent. What was I thinking? Hypotenuse over adjacent. So 13 over 5. Cotangent is adjacent over opposite. So adjacent is 5, opposite is 12. That's one we had to figure out. And then cosine, we're going back to one of our original ones we've used a bunch of times. So 8 adjacent over hypotenuse. So 5 over 13. All right, and then we're going to click check. Maybe. There we go. Okay. Next, clear. Okay. So let's go ahead and label this up the way we need to. So here's our angle of focus. We have opposite. We have hypotenuse. Okay. Writing sideways. And then adjacent, it's between the angle of focus and 90. So here's our adjacent. So we're missing our adjacent. So we need to go through and fill that out because we're going to need all three sides to fill out these functions. So I'm just going to call this one question mark again. So question mark squared plus 5 squared equals, remember hypotenuse is always the one that they equal squared. So we get 25 and 36. We're going to subtract 25 from both sides. And both sides, I mean both sides of the equal sign. So question mark squared comes down. 25 minus 25 cancels. And we get, let's see, we get 11 here. So 11 does not have a square root. So when I take the square root of both sides, I'm going to end up with question mark equals the square root of 11. So this equals the square root of 11. So now we're going to fill in our ratios with, oops, I don't want a double one. That's silly. Boom, boom. Okay. So sine, that's one of our original ones, opposite over hypotenuse. So we want opposite over hypotenuse. Secant is opposite over adjacent. So secant is opposite, which is 5, adjacent, we need to hit square root and then 11 like that. And then tangent is opposite over adjacent. That's one of our originals. Opposite over adjacent. Secant. Oh, darn it, this was hypotenuse. Need to slow down and make sure I'm reading the right ones. Secant, that's hypotenuse over adjacent, not opposite over adjacent. Sorry. So hypotenuse is 6, not 5. Tangent is opposite, which is 5, over adjacent, which is square root 11. All right, check. Clear. One more of these. Okay, so let's go ahead and label our pieces here. So here's our angle of focus. This is our opposite. Our hypotenuse is across from the 90. And our adjacent is between our angle of focus and the 90. And we don't know our hypotenuse. So here's our question mark. So now we're going to do a squared plus b squared equals, we don't know, c squared. We have 49 plus, I don't know, 24 squared. So let's go ahead and look at our calculator here. So we have 24. In order to do square on here, you click this button, and then that little box pops up, and you just have to tell it what your exponent is. In this case, it's a 2. Then I can hit equals. All right, so I get 576 equals question mark squared. And let's just go ahead and keep using the calculator. So plus 49 equals 625. So I get 625 equals question mark squared. I need to take the square root of both sides. Let's see, does this have a square root? So it's already highlighted. So if I click this button, it'll automatically put it in the way I want. It does, so it's 25. So 25 equals question mark. Go ahead and close this. And reopen. Equals 25. Okay, so let's go ahead and fill in our ratios here. And I'm going to slow down and pay attention so I'm not writing the wrong one. So cosine is adjacent over hypotenuse. So adjacent is 7 And hypotenuse is the 25 that we just figured out. Tangent, that's opposite over adjacent. And cosecant, that's hypotenuse, which is 25, over opposite, which is 24. Okay, so we should be good to go here. Yay, we're good to go. We finished another one.